This video, we're going to talk about division of radicals or dividing radicals, which is also from 15.4. We're going to look at numbers 35, 37, 39, 41, 43, 45, and 47. And we're going to use the general property here that the square root of a over b is the square root of a divided by the square root of b. And that property works both ways. We may take a square root divided by a square root and put it under a single square root sign, or we may take a fraction inside of a square root and split it up into individual square roots to be able to accomplish our desired goal here. So let's go ahead and start with the square root of 490 divided by the square root of 10. We're going to rewrite that as the big square root of 490 divided by 10 is the square root of 49, which is 7. Next, we have the square root of 9 divided by the square root of 3, which will be the square root of 9 divided by 3 is the square root of 3. Next, we're going to have the square root of 90 divided by the square root of 2. It's going to be the square root of 90 divided by 2 is the square root of 45, which is the square root of 9 times the square root of 5, which is 3 square roots of 5. We now have the square root of 75y to the 13th divided by the square root of 3y. It's going to be big square root 75y to the 13th over 3y. 75 divided by 3 is going to be 25. Y to the 13th divided by y to the 1st is going to be y to the 12th. We're assuming all variables are non-negative numbers here, so that wouldn't matter in this problem. The square root of 25 times the square root of y to the 12th is going to be 5y to the 6th. Right? Let's look now at the square root of 80 divided by the square root of 2. Is the square root of 80 over 2 is the square root of 40, which is going to be the square root of 4 times the square root of 10 is 2 square roots of 10. Now we have root 60 z to the 9th divided by root 3z to the 7th. Big square root 60z to the 9th in the numerator, 3z to the 7th in the denominator is the square root of 20z to the 2nd. This is going to be 4 times 5 times z squared is the square root of 4 times the square root of z squared is the square root of 5. I'm just pulling out all the pieces that are perfect squares here. And give me a 2z root 5. Again, I'm assuming that z is a positive real number, but if it wasn't assumed to be so, I'd have to put absolute value bars around z. All right. And let's look at one more problem here. the square root of 96 x to the 5th y to the 4th divided by the square root of 3 x to the 3rd y. It's going to be big square root 96 x to the 5th y to the 4th over 3x to the 3rd y. So 96 divided by 3 is 32. 5 minus 3 is 2. 3 minus 1 is 3. 32 is 16 times 2. Square root of x squared, square root of y squared, and an extra y left over is 4xy root 2y. And again, if these were not assumed to be positive values, then I'd have to put absolute value bars around them, but they are assumed to be positive values. So I'm going to leave it just like that. And that is our last problem in this video. And when we come back next time, we will talk about how to rationalize denominators. See you for the next video.